So let me introduce myself a little bit. My name is Kenji. I was born and grown up in Tokyo, Japan, and then I started my career in Japan company. But the 2001, I moved to the San Francisco. Since then, I worked for the San Francisco startups for 2 decades, and then came back to Japan as a solo work. I work remotely right now. I'm a director of the new markets at Alpaca. So today, I like to introduce the building the financial infrastructure at the global scale. Right. First, let me briefly, introduce the Alpaca. So the company was founded by two Japanese guys back in 2015, and over the decade, from the technology company, they transformed to the online broker dealers. So right now, we provide two main products. One is a trading API for individual traders. Another one is a broker API. Basically, it's a B2B2C business model. That means we make a partnership, 280 partners globally, and then we provide brokerage as a service for the US stock markets and crypto. Today, we reached the 9+ million accounts. We cover 40 plus countries, and we have 280 employees globally. And just this month, Alpaca raised the CSD funding, and we raised 150 million. So now the valuation is exceeds 1 billion. So we are in the unicorn cloud. We also secure additional 40 million line of credit. How are we going to use that money? So two directions. One is we're going to strengthen global investment infrastructure, and another one is we try to expand the regulatory licenses in key jurisdictions. So how do we do that? Today, we cover these countries, and then in addition to that, we try to establish our direct licensed broker in those countries. We plan to expand more, but that's a kind of our vision at this moment. What does it mean? So that means we have to keep stock records and general ledgers in multiple countries because the regulations requires independent, isolated books, stock records. It's how many stocks are held by Gun, and also money balances, general ledgers, and often many countries requires data residency. So we have to keep the data in local countries. Orders executed in US, but like a fund and fees, calculation needs to be managed locally. Plus, there's a variation of the jurisdictional rules. For example, Islamic country has a Sharia, margin rules, which is quite different from Western countries. Okay. So from a very, very high level view, what we do is basically we take order from our parties. The partner provides like a mobile application, web UI, and for example, Alpaca Japan is one of a regional broker dealer in Japan of the Alpaca. Take order, and then that one is going to be forwarded to the US system. Eventually, we processing the order management system and then send the order request to exchanges. So that's the kind of real-time part. So it's a request response loop. And once the order is placed in the market, they execute. And the execution may be split into multiple. So it's a kind of asynchronous. From there, asynchronous part kicks in, accept the order management, and then publish the trade events. We use Redpanda as an event stream platform, and we build UTS. This is the kind of central part of the topic I like to introduce in this session. And from UTS, we pass the transaction to the ledger books and records in the US. We also need to propagate the transaction to the Japan, also other countries as well. So, the UTS and then our Redpanda platform is going to be key architecture for us to expand our system globally. So today I'd like to introduce how we leverage, how it's going to be effective for that expansion. Right? So first of all, I'd like to quickly recap what the event-driven architecture. So the left side is like a first part. We take an order. And traditional approach, it's a request response loop. We have a microservices, and then one microservice exposes a REST API takes order. After that, we're gonna pass that order around the multiple services, has a different responsibilities, but eventually it gets to the the final service and then coming back to the response. So that the response loop we need it. However, we also use an event-driven approach. That means we treat it as a message. So the service producer publishes a message, and then we put in that pipe or queue, and that message is asynchronously consumed by multiple services. So it's something like it's a newspaper. Publisher publishes news, and the readers read that paper at their own pace. Okay, and we decided to use a Redpanda as a platform. So for those who are not familiar with Redpanda, let me quickly introduce. That Redpanda is an implementation of Apache Kafka. Apache Kafka is very popular asynchronous platform in the industry. Originally developed by LinkedIn, and then they have founded a Confluent, its own company. The Redpanda is protocol compatible. Okay, however, the implementation is not in Java, and they don't use a Zookeeper. Instead, they implemented a Raft protocol for the consensus, and then the code itself is written in C++. As a result, the performance is much better, 10 times faster tail latencies, and also it can achieve that level of performance with much fewer hardware. So that's a key component for us. For example, we run a benchmark in our real-world data, and with only 4 nodes cluster with 8 CPU and 32 gigabyte, it's pretty humble hardware. However, we achieved a peak throughput, 800 megabyte second, and 200K records per second. So it's pretty high throughput. That one is, 6 times higher than typical usage where we have enough capacity. And the response average is less than 100 milliseconds, and we handle millions of the transactions per day on that platform. Okay, so that's a Redpanda. And today, what I like to introduce is how we build a framework on top of Redpanda. So Alpaca developed a universal transaction system, which is a real-time event streaming backbone built on the Redpanda with flat buffer. I'm going to explain what the flat buffer is next, enabling asynchronous type-safe transaction delivery. So that's a key component for our financial transaction. So what's the flat buffer? Key features, it's a zero copy deserialization. For example, like a JSON, you serialize, and then when you read the deserialize, it has overhead. So with the flat buffer, there's no deserialization. That means we can directly sneak peek the specific part of the data. So that's a strength, and we also, it's a schema driven, so we can ensure the type safety and cross language, memory efficient, fast access. As a use case, originally it was developed by Google and for game engine. Over the time, it has a wide adoption. It's more than 25,000 stars in GitHub. It's a Apache license, so we use a high performance API, low latency requires the system. So that's our use case. As a result, we have a core data flow serialization as you described. In addition to that, UTS has a consumption and access multiple consumer groups per topic. That means we can build application to consume the same set of the messages for different purposes. For example, one for US ledger, another for Japan ledger. So we can build multiple application consuming simultaneously. Another one is a direct API consumer with a field level access, so we don't have to deserialize. So that type of features. Plus, we build a dead letter queue support. As a financial institute, we have to reliably process the system. If some downstream system goes outage, we have to keep that data for the future deconsumption. So we have a robust DLQ system. And obviously, another big thing is idempotency. So once we process the data, we don't want to process the same data again. So we have such a mechanism. The last one is observability and consistency. We had like a centralized Prometheus matrix, Grafana dashboards, and then we, maintain like all kind of matrices built in, battery included. Okay. As a result, what we achieved was the performance. The performance of flat buffer is 4 times faster than protobuf. So it's definitely, we gain speed. Also, zero copy deserialization means memory efficient. And another thing I like to highlight is schema evolution. If you have experience to deal with the schema registry in a Kafka, it's really cumbersome. Usually, you have to manage a schema in Adro and other type of things, backward compatibility and all kind of hassle kicks in. Because flat buffer has a schema information within the data itself, so we don't need to maintain separate schema registry. So that's a big win. And as a result, obviously, we get the type safety and observability and reliability. So the UTS produce their own schema, which means that always the challenge is, who maintain the schema. So that's a big challenge of the event-driven architecture. And at Alpaca, we decided to use producer own schema model, which means producer repository. For example, the previous presentation, OMS publishes the messages, right? So OMS is the publisher, and a publisher has a responsibility to define and maintain the FBS schema files. It's a flat buffer schema, and then producer team controls the schema evolution. Okay, so producer knows the data, and we have like a CI/CD pipeline, and when producer define the new schema in the repository and push it, we kick the GitHub actions to transfer the schema to the one central place. So we have many different producers, but we have one central UTS client repository to accommodate all of those schemas. So and code generator creates the Go types automatically. Consumer can leverage all features, IDE, IntelliSense, and that type of stuff. So consumers simply import UTS library in their application, and all necessary schema information from producer already exist. That means we can get the benefit of the strong type safety, and it has a data transfer object everywhere. Okay, so that means the benefit is no dependency hell, because we don't have to worry about the producer versions. We just import the UTS client, that's it. And a clear ownership and automatic synchronization because of an automation system, and version visibility with a Prometheus matrix. That's another benefit. So how UTS empowers globally distributed environment? One thing is we leverage asynchronous flow, eliminates direct service dependencies, so it scales. For example, like Alpaca Japan needs to consume data from the US system. The latency between the GCP Japan region and then US region is, like 150 milliseconds to 200 milliseconds. It's a huge by our standard. And because we take an asynchronous approach, we can absorb that level of latency. So that's a good thing. Second thing is time zone fluidity. So we have separate teams globally. We have developers in Europe. We have establishing team in APAC, including Japan. So sometimes like a coordination, if we need to coordinate producer and consumer development teams, it's going to be a blocking factor. Because we have a clear contract in the form of the FPS, flat buffer schema, we can develop asynchronously. So that another big win was. Okay. And the second thing is schema-based contracts. Ownership is producer. So producer has a 100% control. And for the consumer side, they need to simply import the latest UTS client if you need the latest feature, right? And the last one is key outbound. So we have like the high velocity independent deployments and the reduced overhead. This is critical because again, like we have more than 180 engineers globally, and we cannot coordinate everything. So we have to give each team as autonomy to develop independently. So that will be the big win. And then regional independence with global consistency. So that's another thing. And the third one is a scalability. If we need to add a new country to support, we can simply add a new consumer. It doesn't affect like a throughput of the producers. It scales. So, and then lastly, today we have people from Alpaca. I also want to call out Hitoshi. He is one of like co-founders. So he is a guy who founded the company that grew Alpaca to the big 1 billion unicorn status. So please ask a question if you have a startup experience, and then the business questions as well as the technology questions. We also have Jackson, Brandon, Brian. They're all engineers. Please ask a question. We also have a couple of additional DevOps engineer out there. And we have Sayuri and Karako. They know like a business side. So if you're interested in how to manage startups, projects, and kind of stuff, they are good sources. All right. That's all. Thank you.